Here's a problem for you if you are preparing for the Oxford and Cambridge interviews this year, and if you're looking to study maths. My name is Jamie and I studied maths at the University of Oxford, and now I help students all across the globe who are looking to get into these top universities to study maths. Let's have a look at this one. We've got the numbers 1 up to 7, and we're going to replace any two numbers, a and b, with ab plus a plus b. We want to repeat this until there's only one number remaining. Show that the final number does not depend on the choices made, and determine what it is. I'm going to suggest you pause the video and have a go at this problem, and if you are actually preparing for the interviews, try and answer this right now. So you've seen this question fresh, pause this video and try and explain your thoughts. Maybe grab a piece of paper and imagine you're doing this as if it were in an interview. Now I'm going to respond as if I was an interviewee, someone who, you, the student, and I'm going to show you or be telling you the things that you should explain or talk through whilst you're solving this. Okay, I'm going to try and go in and out of interviewer mode. So I'm going to start as the interviewee. Okay, so my first thoughts are perhaps what I could do with this problem is maybe try firstly some smaller numbers, because 1, 2, 3 all the way up to 7, that's quite a lot of numbers. Maybe if I just started with 1, 2, 3, I could potentially spot a pattern there. Another thing I'm thinking is, well, supposedly the final number is always the same, so maybe I could just work out in one choice of like these a's and b's. So maybe if I start with 1 and 2 and do a plus b, that would give me 2 plus 1 plus 2, that's 5, and then do 5 times, and then do 5 and 3, and then whatever that number gives me, put that with 4, then whatever number that gives me, put it with 5, and so on until I get up to 7, and see what this last number should be. And then I kind of have a target to work towards. Or maybe, yeah, I think those two are at least the initial thoughts I have. What I'm going to do is maybe play around with a smaller case. Cool, now I'm going to go back out of interviewee mode. So imagine I'd said that, so that's good. Notice I haven't written anything down, and I've just explained my thoughts to the interviews, laid out my ideas. This is something I always suggest you do once you're given the problem, is to lay out your ideas. There's a couple of reasons you want to do this. Firstly, it's so, let's say that there's 3 potential methods. In this case, there were 2 methods that I kind of mentioned. Either I could try a smaller case, or I could maybe try and find out first what this candidate number is. And I lay these out so then if I try one method and that doesn't work, and let's say we run out of time, at least the interviewer knew I had this other option that I would have eventually gone down if I had more time. But equally, it's also the case that if you go down method A, and method A actually works, then the interviewer never knew that you had method B as a backup just in case. So it's really important that you lay out your ideas. Also buys you a bit of time to actually think about how this problem works. So laying out your ideas is super crucial, and notice that the laying out stage doesn't it doesn't take too long. I'm not giving them a whole speech about some potential ideas, just maybe 10 seconds per idea in terms of how you might approach this. Okay, let's go back into interviewee mode. Okay, cool. So my first thought is maybe I can try this with the case of 3, because 3 seems quite small but manageable enough. If I just did it with 1 and 2, there'd only be one choice for A and B anyway, so I may as well start with the first non-trivial case, which is 1, 2, 3. Okay, and let's maybe play around with this. So if I call the numbers x, y, z, I kind of want to show that this is independent of my choice of these numbers. So maybe if the first 2 numbers I called is x and y, so I get xy plus x plus y, and now I'm multiplying that by the remaining number, which I call z. That would be my AB, and then plus A plus B. Now, okay, let me just maybe clarify what I've done there. So I've taken 2 of these numbers from 1, 2, 3, called them x and y, and let me maybe give this function a name just to make this a bit clearer. And I've calculated f of xy. And f of xy is this guy here. And then what I've done is that would the 2 numbers x and y I'd replace with f of xy, and then I still have z, and then I replace that with kind of f of xy z, like so, and that gives me this expression here. Okay, well if I expand this out, I get xyz plus xz plus yz plus xy plus x plus y plus z. Oh, this looks quite nice. In fact, this looks very, very nice. This is the expansion of x plus 1 times y plus 1 times z plus 1, just subtract 1 there. And actually, now that I think about it, f of ab, this is a plus 1 times b plus 1 minus 1. That feels quite nice. So f of ab was a plus 1 times b plus 1 minus 1. And then when I had three numbers, it was kind of, you add 1 to those individual numbers, multiply them together, and subtract 1. And now also notice that when I do, like with my choice of x, y, and z, because this expression here is symmetric in x, y, and z, what I mean by that is if I replace x's, swap the x's and y's, or swap the y's and z's, or whatever, in any way, the result won't change because I've multiplied these three brackets together, and essentially they're all the same brackets. If I swap x and y here, I get y plus 1, x plus 1, z plus 1. So that kind of indicates that the order doesn't matter because these two expressions are the same. So, it works for 3. Why would it work for 7? Well, maybe my observation here is if I do have 7 numbers, let me call them maybe x1, x2, x3, all the way up to x7. So this is just going to be some permutation, of the numbers 1 up to 7. Well, what I can do is I notice that if, sorry, let me just maybe clarify what I'm about to do here. I've got an idea. What I'm thinking is, let's say we want to show that the choice of these numbers doesn't actually matter. We're always going to end up with the same final number after doing this process, 6 times. So I'm thinking, well, if we just imagine we choose before, so we choose the order, so x1 could be 2 and x2 could be 6 or whatever, and these numbers here just form some permutation of 1 up to 7. And then what is it that we're calculating? Well, it's simply f of x1, x2, then that with x3, and then f of that, and then that with x4, and then f of that. Oops, sorry, I forgot to put an f there. And then f of that, and so on up to, well, I could have just written this out, but x7, and we calculate f of that. And what I think will happen is that this will just end up being x1 plus 1, x2 plus 1, and so on up to x7 plus 1 minus 1. Now, obviously that's not approved, but that's what I suspect will happen, given that that's what we kind of get with this case of 2 and 3. And so what I recommend, or so not recommend, what I think will be the case is that this formula will uphold. And the way that I can show that is by induction. And now at this stage, the interviewer might chime in and say, yeah, no, in fact, this pattern does work. Or they could say, yeah, let's see if it works by induction. It would depend on what the interviewer wants. But it turns out that you can actually prove that this relationship holds by induction. So in fact, that this kind of proves here that the order doesn't matter, or if you did it by induction, that would show that the order doesn't matter. And then you could just simply find an order that, pick an order for these 7 numbers. So if they ask you, well, what would this final number be? Well, we could simply make x1 1, x2 2, and so on. So it'd be 1 plus 1 times 2 plus 1 times 3 plus 1, all the way up to 7 plus 1 minus 1. So 2 times 3 times 4 times 8 minus 1. So that's 8 factorial minus 1. And that would be the answer to this very nice initial problem. Really, really nice problem, and one which I can easily see being one that you could see in an interview. Very, very nice, very, very elegant, and it's important that we lay out our ideas, then we go in. Obviously, they could be chiming in, giving us hints. They could re-steer the direction which we're trying to attempt this, and it's not necessarily about solving the problem. It's really about explaining your thoughts and ideas. If you found this video useful, I'll leave another video on screen where I solve another interview style problem. I'll catch you over there.